My name's Ben, this is the Midcap YouTube channel. I go over a lot of different backup solutions for emergency power. If you go through all of my videos about power stations, generally I will find what's good about them and then tell you why I likely wouldn't buy it. There are a few units that I legitimately say, this is awesome, I absolutely love it. This has the potential to be one of those units that I absolutely recommend. So we're gonna get into the testing of this video, but I wanna show you up front why I'm so impressed. First of all, it has a 2500 watt inverter, which is a very good size for a unit of these dimensions. There are other units that are of the same similar size that have a smaller inverter, and this has a 2048 watt hour lithium iron phosphate battery, and I've got the expansion battery right here. You can add more expansion batteries, but this is what truly impressed me, is right here on the side. First was that we have an upgraded charging cable. This is an even faster one than what comes with most cables out there. This is a C19 plug, which is different than the C13 and C14 that you see out there. But also, we have 12 to 150 volts and 15 amps for DC input. And not only that, comes with an Anderson connector. These are extremely common, non-proprietary. I love to see that with companies where they're trying to support the customer and not having to use proprietary, difficult to find equipment. But what really impressed me, the biggest thing, is the expansion battery has the same solar input. So for every battery that you add, you get the same 12 to 150 volts and 15 amps of input for solar. That is what truly blew me away, because of all the other systems out there, I mean, every single one of them, there is not one that has the battery pre-built with the same charge controller as what's in the main unit. That means as you expand, your solar input goes with your battery expandability, making it much better for long-term power outages to get a fast recharge on the unit. So let's go ahead and get right into this review. We're gonna see how well the Mega 2 does, going through all the tests. So let's go ahead and jump right into it. My first impressions right out of the box is it's got a fast wall charger built in, and the cable is just this 4-foot cable right here. So I do have an extension cable on it so I can reach the outlet on a different unit. So this says up to 16 amps of input, up to 120 volts. That's really fast wall charging. I've seen it get up to 1500 watts. I don't know what the rated input is. What really blew me away was what's on the side here. The 4-point battery expansion cable is very similar looking to other big name brands out there. So we know that's a reliable cable, but it's actually longer. It's a better cable than provided by other providers out there of power stations. I'm still blown away that this has its own solar input here. As far as the cables, you get a wall charging cable. You get this Anderson power pole to MC4 adapter. The biggest concern I have with this is how thin these wires are. It doesn't say anywhere on the red or black here the actual gauge. It feels closer to like 14 gauge. So I don't know that it can actually handle the full 15 amps. But the good news is if it can't, that's something that Oupes could replace. Because this is a common cable, you could easily replace this and get a much thicker gauge for like 10 bucks. Now I don't know what this cable is. It is an Anderson to Anderson power pole. It's like 2.5 feet long. So once I go through the user manual, maybe we'll see what that's for. This one as well is an Anderson to an 8mm barrel. So I know that panels like the Jackery panels come with built-in 8mm barrel connector. So I'm wondering if they just included this to help people have the choice of whatever portable panels they want. And then of course we've got the car charger. This is about 2.5 feet as long as well. Just has your male DC 12-volt plug with an Anderson power pole, and that will go into the same solar input port. So you can't do solar and car charging at the same time. But that's perfectly fine because I've never personally been able to do that. Because if you're charging it in a car, then where would you have the solar panels unless they're strapped to the roof? And just to be upfront, Oupes did send this unit out to me as well as the solar panel. It will not affect my review in any way, shape, or form. I'm 100% upfront with you guys on everything. So if something fails here, you're gonna see it right with me and I'm not gonna cut that out. The warranty, wow, 3 years on the power station. Solar panels is 1 year and the cables is 2 years. That's pretty cool for the warranty card. It does have an app. So for that Anderson cable that we don't know what it is, just this, it just says Anderson cable. So it must be an extension of some kind. I don't know why that would be included. You know what, actually, I bet because this has a 12 volt 30 amp output on the DC, I bet that's what this is for. Is oftentimes we use that with like ham radios or 12 volt high amperage items. So you'll plug that in right into here, and then you can have power to whatever 12 volt device. I'm betting that's what it is because one of these came with the main unit as well as one with the expansion battery. And if you didn't notice already, the expansion battery has its own 12 volt plugs, including 100 watt USB-C. It's got 2 of those. So that's really impressive that you could not have the main unit and still get DC power out of this as well as solar input. You could effectively have like a ham radio only setup with just the battery, no inverter, no power station, no RV plug, anything like that, just a 12 volt setup right here with solar input. Honestly, I think that's super cool. No way. It says its peak power is 5,400 watts. Peak power is just when the inverter has to go higher than its normal running rate. Sometimes you'll get that with sump pumps or water pumps, whether you're trying to move water, get water out of a basement, sometimes vacuums. Anything that has a motor that has to like spin up to speed, it'll usually have a really high peak, and then that energy will come down to a higher continuous load. We can do up to 1,600 watts of wall charging speed. I've seen it get to like 1,500. Doesn't seem to be exactly steady. I'm not sure why. PV input. Oh, wow. 12 to 150 volts DC, MPPT 18 to 140 volts, 15 amps max. 2,100 watts max input. We're gonna put that to the test here shortly. It's a LiFePO4, 51.2 volt battery, and its working temperature is from 0 to 40 degrees Celsius, weighs about 48 pounds. The default standby time is 12 hours, which means if it doesn't have any energy used for 12 hours, it's automatically going to shut off. It does have a slow charge option, so if your outlet is not rated to 16 amps, or if you want to not work the battery as hard, it does have a slow charge option. Now, when you add expansion batteries, obviously you want to do that with the whole system turned off. Don't be charging with DC input or AC input when you add the batteries. It shows 2 extra batteries here, but it doesn't say how many batteries you can add. If you can add up to 2, which you clearly can, then it matches the other similar systems, the EcoFlow Delta 2 Max and the Bluetti AC200 Max, as well as like the Pecron 2000 LFP. Those are going to be the ones that are going to be competing with this Mega 2 from Oupes. And so far, this one would have equal or more output. It's cool that it has the RV plug built in, but the solar input at 2,100 watts is definitely going to beat all of the other systems out there by double, which is pretty cool. But it doesn't say how many batteries you can add. It does have an EPS function, so we're going to test that here shortly. And what EPS means is, let's say I am running a heater or a refrigerator or a water pump, whatever it is. If I've got something running on here and then this is plugged into a wall outlet and these batteries are at 100%, the energy is going to pass through the unit and go directly to what I'm running, not going to the battery first. The reason that's important is it helps prolong the life cycles of the battery. It's a really smart design to do that, because a little bit older units, they would have the energy go into the battery, which means it has to convert from AC to DC, so you have an efficiency loss and heat gain, and then you've got to come out of the battery going from DC to AC, again, efficiency loss and more heat. So you would use a lot more energy from the outlet than was required on the device you were running, simply for the fact that it had to go to the battery. Once the battery is full on this, the way that this works is the energy passes through. If it needs to add energy to the battery, it'll dump excess into the battery while still running whatever you need to be running. So that is an impressive feature right there. And it does say you want to run it in an upright position, not on its side, and that's simply for the fans. You could use it on its back. You just don't want to block the fans because you need to be able to get the heat out of it. And I get that question surprisingly semi-often, because oftentimes in a van life or RV or small cabin, something like that, you may not be able to stack these under a bed or under the couch, behind the couch, whatever it is, in a convenient way. So sometimes people need to tilt them, put them in different configurations. Normally that's okay, but you don't want to do it on its side here, just because you'd be blocking the fans. As long as you're not blocking the fans, you shouldn't have an issue. So I'm getting consistently about 1,500 watts for AC power in, but I need to get solar input on it because it is a sunny day, but we're just about to get out of our solar peak hours. I'm gonna go ahead and connect 4 400 watt panels, because that's gonna be less than 150 volts, and that'll be roughly 11 or 12 amps. Let's go ahead and get solar connected to this. These are the solar conditions right now. So we were in that patch of blue just a minute ago, but now we've got these clouds coming in. So we still got good shadows on the ground, but it's not going to be perfectly clear sun. Okay, so I've got my line 1 here. This has got 4 400-watt solar panels. And we are at 146 volts VOC. I'm gonna go ahead and connect that into the main unit here, and I'll show you why I've got this 2-to-1 branch connector on here. So remember, it was at 146 for the voltage. I'll see both of them are charging already. That's cool. For line 2, which has the same amount of panels, 145.5 volts. So right now, only getting 200 watts input. Very low. Yeah, those clouds are really sucking up a lot of the sunlight. Let's see what happens here. So now I've connected to the second unit. Okay, so it has this own display here for solar input, it looks like. Now I don't normally recommend that people do this, but I wanted to demonstrate what the difference is between VOC, which is open circuit voltage, and VMP, which is voltage at maximum power. Your VOC is voltage before charging, and VMP is your voltage after charging has begun. So remember, we're at about 146 on our voltage, but now that we have amperage coming in, what I'm gonna do is I'm gonna put these right into here, and we now see at 137 volts. So the voltage gets lower. You have to make sure that when you're plugging in, that 150 volt maximum is your VOC number. So I took the 4 solar panels, and then I took the VOC and multiplied that by 4. That told me my total VOC going in. That's how you safely connect stuff to these units. You do not want to exceed the voltage because you will most likely fry the charge controller. And if we go to our amps here, only getting 2.7 amps, 2.8 amps. So the amps is what's going to change the most. And we can see we're going up to 400 watts. And all we have to do is take the voltage that we got, which was about 137, multiply it by however many amps we're seeing, and that's going to tell us our watts input. Volts times amps equals watts. So I think I know what's going on. So here we're getting 450 watts, here we're getting 250. The panels that are connected to this unit, there is a tree close to it, and it must be partially shading it. Here's what we're going to do. We're going to swap these and see if it changes our input at all. The only thing that I probably would recommend that I think all companies need to be supplying is a DC switch for the solar cables. Very similar to this one here. So the short side here on this one is the input and this is the output. The switch here is what allows you to control turning power on and off from the solar panels. Because when I went and plugged this in, this would be normal with any unit, this cable is energized. It has power from the panels. And so when I plugged it in, sometimes you can get a little spark. If you have this, you have it in the off position, you get everything plugged in, then you switch this, then the wires are already touching and you don't get any spark issues. So I think every company should include some sort of DC switch like this, but pretty much nobody does except for one company, but not necessarily a problem for the Mega 2, but just something to be aware of. Okay, interesting. We're actually getting very similar solar input here now, in about 350 and 370. So I'm gonna go ahead and switch these back again. Well, they seem to be pretty much the same once again, but what I'm gonna try is a couple of my own Anderson power pole adapters, because this is a little bit thicker wire. I wanna see what happens. Now the conditions are constantly changing, so we have to factor that. This is more of just experimenting. It must just be the clouds giving us a lot of problems. I'm not really noticing any difference between input between these other wires versus the ones that they supplied. So they must work about the same. But I do have their 200 watt portable solar panel here. Let me show you that. The nice thing about this is it has these propped up legs that you can stick out of the back. And it sits at about a 45, maybe closer to a 55-degree angle. So a little bit on the aggressive side. And basically each one of these is a 50-watt solar panel for a total of 200 watts. And it has about a 12-foot cord coming off the back that has a DC 7909, or also called an 8mm barrel plug. So that's this right here, the DC 7909, and this is the male side of it. So this would be able to go into the Anderson to DC 7909 adapter that comes with the unit. But my issue is it doesn't reach my unit all the way in here. So what I'm going to do is I'm going to adapt this to an MC4 and then go back into Anderson so I can make this work. So in order to do this, I have my male DC 7909, which is coming from the panel, and then I've taken this DC 7909 to Anderson adapter that came with the system, plugging these two together, which makes sense. And then I have an Anderson to MC4 adapter that I'm just going red to red, like so, and then black to black. And that allows me to get to this MC4 cable to reach the Mega 2. So double checking, I've got my red and my black on my red and my black, and we're at 22.4 volts. You have to make sure that you check the voltage on this, that it's not reversed, because not all Anderson to MC4 connectors are wired in the same way. So we got our voltage in the right range, and positive on positive, negative on negative. Let's see what happens with this 200 watt panel in the shade, sort of sunny. I was wrong, it's actually a 240 watt solar panel, not a 200 watt. It says it's 20 to 22% efficient. Power voltage, that's your VMP, is 19.8, and current is 12.1. And it looks like the stands on the back of the panel are adjustable. Well, only getting 77 watts right now. That's to be expected because we have the clouds. But that is cool that they have a 240 watt panel. I thought it was a 200 watt panel. It's very compact. And in the diagram here, it does show you how to connect lots of them together. And so the way that they want you to do it is if you're using a bunch of their panels, is you actually convert each panel to use a DC 7909 female to an MC4 adapter, and then you put all of them in series, and then it goes into a single solar cable, which then goes into the Anderson power pole. That sounds a little bit confusing. That's okay. It is straightforward. You're just basically going to convert each one of these panels to an MC4 adapter. I'm not sure why they didn't just do MC4 to begin with, because then they could have been used with other units as well, and then theoretically they could sell more panels to other people to use on other units. But either way, that's how it's working. So it works with huge 400 watt panels as well as portable panels, and that's awesome. So the other thing we need to test here is the EPS function, which is the pass-through, or kind of the UPS. So we're outputting 1100 watts. This usually pulls 1200 watts or so. And our input from our AC is 500 watts. So in total, we're at the 1600 watt rating of what it said it would do as the AC input was going in. So that must be what's going on here, is because this is drawing about 1100, the excess 500 is going into the batteries and still getting a charge. Now I'm going to go ahead and disconnect the wall charger and see what happens. We're going to watch this light and this wattage to see what happens. Okay. So it did transfer, but it took probably half a second. That's definitely one of the slower UPS or EPS functions that I've seen. It's supposed to be close to like 20 milliseconds. Go ahead and plug this back in. It says we're using 1200 watts to run this. So this drops down a little bit to 1100 watts once the wall charger is in. So what we see here is we're using about 1600 watts into this unit, with 1100 going to the load and 500 going to the battery. And then here on this unit, which I am drawing from to power that, we can see 1678 is what's on the output, 1652, in order to be running and charging the Mega 2. We'll try this one more time. I'm gonna go ahead and pull the plug. See, that time, there was like no delay at all. There was barely a flicker here, and it's still running everything. So maybe not 100% the absolute top best UPS if you were running like a server or a computer that can't take a slight delay. But a lot of people are just using laptops or something that has a battery in it, and that would not be a problem at all. So the EPS function is working. However, I don't know that it's the fastest one out there. So I'm doing a 0.3C drain right now. I've been gone for the last few hours, and we're at 16% here, 23% here, 1200 watt load out of a 4000 watt hour battery is 0.3C. So usually I do the test at 0.2C. So we're gonna have to give it a little bit of credit, but we're gonna see at a 0.3C what the efficiency is. So far, not super excited, but you never know. Sometimes it'll sit at 1% for a really, really long time. So once this is done draining, then we will charge it back up and see the total round trip efficiency of the whole thing. We officially reached the end. Error 02 is a full drain. Let's see if it's got enough juice to turn on the outlets. Doesn't look like it does. Oh, it does. Does it? Wow, okay. 3.68 kilowatt hours. Wow, I'm actually very surprised. Very, very surprised. That is 90% out of the battery. That is very impressive. The only other unit that I've really seen that is that good on efficiency is the Apollo at 91%. So Oupes absolutely hit it out of the park here with the Mega 2 on terms of the efficiency out of the inverter from the battery. Now I'm going to go ahead and reset this, and we will see what it takes as far as input to get this back to 100%. It is now the next day, and we are at 100% here. Let's see how much it used to get back to 100. Well, this is very interesting. It says it used 5.25 kilowatt hours in order to get fully charged again. The part that's confusing is that it used that much. So that's like 20 to 25% more than the rated capacity. But I left it on all night, and I don't know if that makes a difference, but those are the numbers. So overall, I'm very impressed with this unit. The fact that it has a 2500 watt inverter is good. You're not gonna be able to pair two of them together to get 240 volt power. That's okay. This is a middle cap to heavy cap sized system. It's not designed for running houses. This is more of a portable backup because it is light enough to pick it up and take with you places, but still strong enough you could add extra batteries, add lots of solar, and run your RV. This would be capable of running an air conditioner as well as the fridge, but because those use so much energy, you would probably need 4 or 5 extra batteries at a minimum to make that work. The beauty is being able to expand with that many batteries would make it so it's a possibility, because then you can pull it out of the RV and run things like the fridge, freezer, lights, fans, Wi-Fi, a window air conditioner, CPAP machines, medical devices, all of that. So this would make a really good backup system. The solar input is what impresses me the most. They really paid attention to that. That's one of the #1 things that I harp on here on the channel, is not having enough solar to go into these power stations. Looks like Oupes is paying attention, and they went overboard on it because now every battery has the same MPPT as the main unit, but you will have to over panel in order to get the max solar input, simply for the fact that even with my 400 watt panels, I can only connect 4 of them together in series. That's 1600 watts, and this is rated to 2100 watts. So I would need a second group of 4 panels in order to be able to get close to that 2100 watts of input. So I have to have 3200 watts of solar input to get the 2100 watts. That's not abnormal for systems, but even systems like the EcoFlow Delta Pro, which has the same parameter, the 12 to 150 volts and 15 amps, but is limited to 1600 watts. It is very hard to get more than 1400 watts into that big system. And this, the smaller system, is capable of getting more than the Delta Pro, but it can't do 240. So there's a give and take there. You would have to decide which one you'd want to go with. Bottom line is the best systems that I recommend are all on poweredportablesolar.com. And I'll also include links for this in the description down below with any coupon codes that I can get you guys if it interests you. For me, this 100% gets 2 thumbs up. I've had a good experience talking with the customer service. The solar input is great. The output is great, including the 12 volt output. I would say the biggest limitation is the app. The app is not as straightforward as many others. I couldn't get it to work 100%. So maybe there's some kinks there that need to be worked out. But overall, I absolutely give this 2 thumbs up. The efficiency is incredible. The solar input is incredible. The AC output is sufficient, and the expandability is great. So for all those reasons, I like it. If you disagree, let me know. If you do agree, let me know. The comments down below are meant to be there to help you to have a discussion about what the pros and cons are of all of these systems. I would use this as an emergency backup system, and I would probably get 3 expansion batteries. I find that a minimum of 6,000 watt hours is the way to go. So if I can be above that, I'm quite comfortable. Like today is a very cloudy day, so I probably won't get much sun, which is why having the extra batteries is a really big help. Or start with a smaller system and then expand to a bigger system down the road. That's why I like expandability between these systems, and it's way easier than a DIY system to expand because you're just using these cables right here. Thank you guys so much. Be prepared. I'll see y'all in the next video.